Hi, FOM 12 students. Here are the answers to the 6.2 homework. It was from the textbook, pages 393 over to 397, and it's numbers 1, 2, 3, 6, 7, and then 8, A, C, and E for number 8. Okay, and so we'll start in with number 1, and it says determine the degree, the leading coefficient, and the constant term for each polynomial. And so it gives us a list of polynomials here. The first one is f of x equals 6x squared minus 3x minus 2, and it wants us excuse me, to determine the degree for each of these. So I'm going to put like these little columns. Degree, the leading coefficient, the degree, the leading coefficient, and the constant term. Okay, so we'll do this in just a second here, guys. I'm just getting the back of the book ready so that I can make sure I'm not making any mistakes. Okay, so for this first one, I have it down written properly. The degree is the highest power of x, so that's 2. The leading coefficient is the number in front of the highest power of x, so that's 6. And the constant term is the term that doesn't have an x attached to it, and that is negative 2. Okay, and if you look at the back of the book, it is consistent with that. All right, letter B. We have g of x is equal to negative 2/3 x plus 10. The degree is the highest power of x, that is x to the 1. The leading coefficient is the negative 2/3, and the constant term is the positive 10. Letter C is h of x equals negative x cubed plus 10x plus 6. The degree is the highest power of x, the leading coefficient is that number in front of the highest power of x, and the constant, of course, is the 6. And let's do some checking back here. Good, things are looking good so far. And letter D, they have j of x is equal to 4x cubed minus 2x squared minus 3x minus 10. So the degree, the highest power of x, is x to the 3. The number in front of that is the leading coefficient, that's 4, and the constant term is negative 10. Excellent. Okay, we are on to number 2. And number 2 says for each function in question 1, determine the minimum and maximum number of x-intercepts of the graph. 2, determine the end behavior domain and range of the graph. And 3, determine the minimum and maximum number of turning points. Okay, so maybe I should set it up like this again. And how we'll have f of x is equal to 6x squared minus 3x minus 2. And we're going to want to do part 1 for all of these. Minimum and maximum number of x-intercepts. part 2, and then I will stretch part 3 over to here. So part 2 is end behavior, domain, and range. Part 3 is the minimum and maximum number of turning points. Min and max number of turning points, TPs. And number 1 is the min and max. Min max number of x-intercepts. Okay, and so the first one here, guys, is an x squared. It's a quadratic. It's a U-shaped graph, and it's facing up because the leading coefficient is positive. So it could be like that and have 2 x-intercepts, or it could possibly be not touching the x-intercept. So the minimum number of x-intercepts is 0. The maximum number of x-intercepts is 2. The end behavior, it goes from quad 2 to quad 1. The domain is all real because it goes from left to right forever. The range is y is greater than or equal to -2. The minimum number of turning points is 1, and that's the maximum number of turning points as well. Okay, and you can see that that's consistent with the answers in the back. Okay, letter B was this g of x equals -2/3 x plus 10. That is a straight line. It's got a y-intercept of 10 and it has a negative slope, so it looks like that. The minimum number of x-intercepts is 1, and the maximum number of x-intercepts is 1. It goes from quadrant 2 to quadrant 4, the end behavior. The domain is all real, goes from left to right forever, and the range is all real, graph goes up and down forever. The minimum number of turning points is 0, and the maximum number of turning points is 0. Awesome. Okay, letter C is h of x, which is equal to -x cubed plus 10x plus 6. The minimum number of x-intercepts, so this is a negative cubic. It could, in theory, do that and only hit in one spot. Or it could do this, 1, 2, 3 x-intercepts. So the minimum number of x-intercepts is 1. The maximum number of x-intercepts is 3. Negative cubics, yes, they go from quadrant 2 to 4 like this. The domain is all real and the range is all real. And the minimum number of turning points, in theory, guys, a cubic could go like this and not really turn back. So the minimum number of turning points is 0. It could turn like this and turn like that in its extreme form. So the maximum number of turning points is 2. Okay, and that is consistent with the back. And finally, letter D, we have j of x equals 4x cubed minus 2x squared minus 3x minus 10. And that's a positive cubic. And again, in theory, it could do this. Or it could do this. So, minimum and maximum number of x-intercepts. The minimum number of x-intercepts is not 0, it's 1. It's got to touch at least once because the graph goes up and down forever. And the maximum number of x-intercepts is 3. In theory, like, you can even have a cubic that looks like this, right? End behavior, it goes from quadrant 3 to quadrant 1. Domain is all real. Range is all real. And the minimum and maximum number of turning points. The minimum number of turning points is 0, like this situation where it doesn't really turn back. And the maximum number of turning points is 2. Okay, so there's number 2. Let's move on to number 3. And it says determine the degree, the sign of the leading coefficient, and the constant term for the polynomial function represented by each graph below. Okay, so they want us to figure out the degree, the sign of the lead coefficient, and the constant term. Okay, remember that the constant term is always the y-intercept of the graph. Okay, and so in A, we have a graph that is like this. That is a quadratic, an x squared, so that's a degree 2. The sign of the leading coefficient is negative because it's facing down. And that graph touches the y-axis at 2. I'm just looking at the picture of it on page 393, so you'd actually have to look in the text to see the picture properly. Letter B is like this. That's a straight line. That is linear. That is x to the 1. Right, this is kind of an x squared. This is x to the 1, so the degree is 1. It's going up and to the right, positive slope, so positive leading coefficient. And it also is touching 2 on the y-axis, so that's the constant term. Letter C looks roughly like this. Okay, so that's a cubic. That's an x to the 3, so it's degree 3. It's moving up and to the right, so the leading coefficient is positive, and the constant term is the y-intercept. It is hitting the y-axis at negative 1. And then letter D looks like this. That is an x to the 3 graph, so the degree is 3. It has a negative leading coefficient because it's moving down as you head to the right. And the constant term is the y-intercept of 6. Okay, and back of the book seems to agree with that. Okay, so we are on to number 6 now, because we're supposed to do 6, 7, and then a few in number 8. Number 6 says match each graph with the correct polynomial function. Justify your reasoning. So number 1 is a negative cubic. A is linear, C and E are both quadratic, D is linear, B and F are the cubic-y kind of shapes. And when it goes down and to the right, it's got that negative leading coefficient. Okay, so very roughly this would look like this, right? Okay, and so the answer for this one is B. Number 2 is y equals 2x squared plus 6x plus 4. The 4 is the y-intercept, and since it's x squared, it's a U-shaped, and it's facing up because the leading coefficient is positive, so it should look like that. Oh, I didn't really do that entirely right. The vertex doesn't necessarily have to be on the y-intercept. So as long as it's something like that with a y-intercept of 4, okay, and so that is graph C. Now number 3 is y equals x plus 1 times x plus 2, and if you were to multiply this out, we would get x squared plus 2x plus 1x plus 2, which is y equals x squared plus 3x plus 2. It's got to hit there. And so that has to be graph E. Number 4 is a y equals x cubed minus 2x squared plus 6x plus 4. So we have to hit a y-intercept like that. And it's got to be a positive cubic. The closest one that goes up and to the right that looks like a cubic is the one that looks like that, which is letter F. So we got B, C, E, F so far. Okay, so that's consistent with the answer key. They just did theirs the opposite way to me. Y equals 3 minus x. That is going to be a straight line with a negative slope. So that has to be D. Oh, hang on. A and D are very, very similar. Y equals negative 2x plus 3. That also has a y-intercept of 3, but a steeper slope. Okay, see how that slope is a steeper negative than negative 1? So that means that part 5 here has to be the less steep one, which is A, and this would have to be D. Perfect. Okay, let's check out number 7. Determine the following characteristics of each function: number of possible x-intercepts, y-intercept, and behavior, domain, range, number of possible turning points. Okay. Okay, let's see. We have to have number of possible x-intercepts, the y-intercept, the end behavior, domain, range, and number of possible turning points. Okay, this is an x to the 1. It's like this, negative slopes. The number of possible x-intercepts is 1. The y-intercept is at 5. The end behavior goes from 2 to 4. For a straight line, domain is all real, and so is range. Number of possible turning points is 0. Letter B, we have v of x is equal to x squared plus 2x minus 6. Since it's got this negative 6 y-intercept, it would be like that. So its number of possible x-intercepts is 2. The y-intercept is the constant term, negative 6. Seems to go from 2 to 1 as we go from left to right. Domain is all real, and the range is, the graph is greater than or equal to negative 6. And possible number of turning points is 1. Letter C, we have u of x equals x cubed minus x squared plus 5x minus 1. Number of possible x-intercepts. So at most, it can have 3 x-intercepts. The y-intercept is that constant term, negative 1. The end behavior, a positive cubic, yes, goes from 3 to 1, like this. The domain is all real because the graph goes from left to right forever, and the range is all real because the graph goes up and down forever. And the number of possible turning points, it turns here and turns here, so there are 2 possible turning points. And finally, letter D is w of x, which is equal to negative 2x cubed plus 4x number of possible x-intercepts for a cubic is 3. The constant term is the y-intercept. There is no constant term, so it's a secret 0. And behavior for negative cubic would roughly go like this, right? So it's going from quadrant 2 to 4. Domain is all real. Range is all real. And possible number of turning points is 2. Okay, let's check some answers for number 7 here. Okay, looking good. All right, number 8, we're supposed to do A, C, and E. So 8A, it says, write an equation for a polynomial function that satisfies each set of characteristics, extending from quadrant 3 to quadrant 4, 1 turning point, and a y-intercept of 2. So we have to hit here. We have to go from quadrant 3 to quadrant 4, so it would have to do this, would have to be a quadratic, and it's facing down, so we would need a negative leading coefficient. So a possible equation could be negative x squared plus 2. Negative x squared graph facing down with a y-intercept of 2. What do they say? Oh, we got exactly the one that they put. There's lots of examples that you could use. Letter C, we've got degree 1, increasing function, y-intercept of negative 3. Degree 1 means it's a straight line, and increasing means going up and to the right, and a y-intercept of -3, so it would be like this. Y equals a positive x to the 1, positive slope out here of, I have it as positive 1, and the y-intercept is -3. So that's an example that could work, which is what they have in the back. Finally, letter E, a range y is less than or equal to 2 and a y-intercept of 2. We have to have a range less than this. What were our graphs? It's either like this or perhaps a quadratic. The only way we're going to get a range of less than or equal to 2 is by using that kind of graph. So y equals -x squared plus 2 again could work, which is what they have. Excellent. There you go, everybody. Those are the solutions to the 6.2 homework. I'll probably just send you one final little math task next week. Perhaps just another fun little problem from a different Crack the Code that we did. And if I don't see you guys, congratulations on your grad this year. I know it was a bit different than usual. Have a good summer, guys. I enjoyed teaching you the past couple of years. And come back and visit anytime. Talk to you soon.